you already learned the category of M&E system, right? We have mechanical system and all its subcategory such as air conditioner, piping system, fire protection. And then we have a second category which is electrical system, all related to electrical and electronics such as lighting system, power supply, and so on. And then the last category we have a building operation system such as building transportation, elevator, elevator, walkways, elevate lagi apa? Tangga bergerak tu, escalator, and then building automation. Okay, so basically in building, as a building services, there are many, right? Many services, many equipment. So traditionally, or current practice of some old building, okay, all building services or all M&E system is being monitored or being controlled manually. Okay, example, air conditioner system has one department to make sure the technician and so on to make to repair for maintenance. So and then for lighting, some another teams, okay, to make sure all the building system works properly. So what happened here is it require many resources, okay, in terms of workers, and is sometimes to find problem is will cause delay, all right, because all things is do conducted by manually. Okay, therefore for future building management or recently also have been developed one system named as integrated building management system. So the purpose is to integrate to in terms of control, okay, in terms of control and monitor all the system in one online system. Okay, all right. So it is called as building management system. Another name is building automation system, BAS. And in some country, they also use the name of building management and control system, and direct digital control, and building control. But as in practice in Malaysia, currently you may see, you may hear about BMS and BAS. Okay, especially I will introduce later in future building, green building, or if the building need to be categorized as green building or smart building, the building should have their own BMS system. Okay. All right. So as I mentioned before, control and monitor means to central controlling facility. Okay, so all the categories lah, mechanical, electrical, and operation. Automate and take control of various operation. Okay, so all of it can work automatically by introduction of sensor. Okay, to manage all the system, we can manage all the system, for example, to switch on, switch off, to stop the operation uh, if something happen, and coordinate various system, right? So all these things, control and monitor, the purpose is to provide comfortable working environment in an efficient way, right? Okay, let's look into. I think before we go into further, let's see one video about in YouTube by engineering and automation. Okay, let's see this video first. Okay. The video takes about maybe 5 minutes. Right, let's see the video first.
Hello everyone, welcome to Engineering and Automation YouTube channel. Today we are going to learn about the basics of Building Management System, BMS. This will be a series of videos where we will be exploring all about the Building Management System. So please subscribe and stay tuned. What is a BMS system? Let's take this high-rise building for an example. This building will have many mechanical, electrical, and plumbing equipments. Mechanical equipment such as chiller, chill water pumps, water heaters, ventilation systems such as air handling unit, fans, etc. Electrical equipment such as escalators, lighting, electrical panels, etc. These equipments will work standalone without any coordinated functionality. For example, to provide comfort in the building, the chiller should be delivering the temperature at a certain degree Celsius. Without a coordinated system, it is very difficult to manage all the equipments manually. This is where the BMS comes into action. BMS connects all these equipments in a centralized manner. BMS controls, monitors, and optimizes the semi equipments using hardware and software components. It is a package of intelligent microprocessor-based controllers which connects directly to these equipments at field level. The controller sends data to a management system where the data taken from the field equipments are translated into a graphical user interface format. BMS provide comfort to the building occupants, energy savings to the client, easier troubleshooting opportunities to the building operator. The BMS system comprises of three main levels. First one is the field level. This level refers to sensors, instruments, valves, actuator, thermostat, IO models, etc. This level plays an important role in the building management system, as the action taken by the BMS system is purely based on the inputs received from this level. Next is the automation level. This can be called as the brain of the building management system. It consists of compact and modular DDC controllers. The DDCs process the inputs from the field devices and takes action to provide comfort to the building occupants and safety and security to the building occupants. The DDCs are freely programmable. The controllers can be connected to a handheld operator terminal to control or monitor the field equipments at the field level without the requirement of any management system. Next is the management level. The management level provides an interactive user interface to the building operator. It displays all the information taken from the field level by the controllers in a graphical user interface format. The management level can either be a PC or an HMI, human machine interface. The management level can also send data via text or email message in case of any critical alarms. The field level sensors and devices are connected to the automation level via hardware connections, typically with a single pair cables. The operator terminal can be connected either via a bus cable or a standard Ethernet cable. The automation level is connected to the management level via backend IP protocol with the use of building structural cable methods. Let's look into the communication protocol being used in the BMS system. The most commonly used protocol is backend protocol, which is a building automation control network protocol developed and managed by Ashtray. It is an open protocol for the BMS system where different BMS systems can be integrated. Next widely used protocol is LONPOP, local operating network. It is widely used in low bandwidth applications. Next is the Modbus. It is a serial communication protocol which uses master slave technology. This is a very old protocol which is being used in the PLCs from 1979. Most commonly used communication protocols are BMS has many features, which makes it as an important system in the building comfort and safety applications. Let's see some of the features here. First one is the graphical user interface. All the BMS system provides a graphical user interface which represents a 2D or 3D view of the equipment. It also displays the sensors installed in the equipment. Next, the most important feature of BMS is alarm management functionality. BMS system provides a variety of alarm management functions. It is also possible for the BMS system to send the alarm information to an external program such as maintenance management software to generate work orders based on alarm descriptions. In order to identify if the equipments are performing efficiently, BMS provides a trend management functionality. It displays raw value in a time-based graph. These graphs can be exported into an Excel format for analysis. Since the BMS system is also referred to as an energy management system, it provides a functionality to control the equipments based on time, known as a time scheduler. The time scheduler lets the operator to decide when to turn on and turn off the equipments. The A to service office can be programmed to turn on only during the work hours, from 7 a.m. to 6 p.m. This is very helpful in many cases where the equipment can be configured to turn off when there is no occupancy in the building. Let's get to know about the history of BMS a little bit.
Okay, I think that's all for the video. So basically, hopefully you get the idea. So basically, the system is to integrated our system, and to monitor and control all the system digitally via online or internet lah. Okay, so all the system that need to be connected, and there has one computer or server that can show the user interface, all the parameter or performance of each system. So the best part of this
Specifically means that IoT
system
public
is
security,
we
the
can
operating protocol
it can give alert. Okay, this part.
provides a custom user
Oh, sorry.
interface.
First thing first is it can show
All the
the 3D
systems
model of the system, where in this system it shows all the location of the sensor, and if at the vote, for example, this is for air conditioning system, so it can shows the real time airflow rate, temperature, and so on. So if something happen and not different from the typical setting, so we can identify the problem. Okay. The next is it can shows it can give notification if the system don't work properly. So it can give alarm. So if something problem, we can give alarm, and then as we can as a technician team, we can go directly to the site to find where is the problem. Okay. This in the same time, by the system also we can use scheduling. Sometimes we can remotely switch on or switch off, for example, air conditioning system at the time that are necessary. So it can make the energy use more efficient. Right. So let's go back to the slide. Okay. Let's review if the building works without the PMS system. Okay. What happens is we need to control and monitor manually. Manually switch on and switch off equipment, manually identify the problem equipment, manually configure the equipment, and manually coordinate the system. So all the things is do manually and need resources. So the impact of this thing is, of course, it requires many work process and tasks. Okay, so many technicians, many tasks for maintenance, all the equipment, and then of course it will reduce working efficiency. For example, delay identify problem, delay switch on or switch off. Okay, for example, if you this is intention such as FCAP. So in my room, if something happen with the connection, so I have to log the aduan. I have to make a comment to get a report to the facility management to say that the condition system is not working well. So then send to them, and then they will generate the report. So from the report, I have to queue. Maybe some others also have report to queue up, and then in some times they will take read my report, and then come to the building and check, try to find where is the problem. Okay, so it takes time. The process takes time, and it will reduce working efficiency. Right. And then it takes time to configure the equipment. Right. For example, if by the MES system we can set all the parameters by the user interface or by the server. But if not by BMS system, they have to go to the site to setting on the site on the location. What is the suitable settings? And then there are delays in maintenance works for the equipment because they don't know without BMS systems, they don't know exactly where is the location, so they need to troubleshoot to check all the system where is the problem with the equipment. But by MES system, they have each equipment have sensor. So if the sensor have fault, so they can directly identify and go to the problem with the equipment. And then normally sometimes in years we need to identify or calculate, estimate the energy consumption for the building. How much we already use. So we have to calculate the meters by the meters, check building by building to know the building energy and water consumption. Okay. But by PMS system, all of this we can get from the computer, management computer, and can get the value of building energy use and water consumption. So much more convenient. Okay. Right. Okay, then the next, as I mentioned before, in future or recently still, for requirement of green buildings such as metric, as you read here, it is expected that this is a requirement to make sure the building is can be categorized as smart building and can score on the green building accreditation. So one of the requirements is expected that smart building is supported by the presence of a building management system, building information modeling, or the automation system. Okay, so there's a requirement to make sure the building can be smart building. Okay, another requirement by, like, for example, Green RE, which is implemented by University of Indonesia. And then there is Green RE by Rekda Malaysia, for example, for water usage. Okay, one criteria can be because it allows us to allocate to building management system and monitoring and detection. So nowadays, so in standards or guideline, now they are shows that the importance of PMS system in building management for building services. Okay. So the emphasis is it is important to have a building management system in the building. Alright, let's see what the main components of PMS. So mainly there are four, which is building automation system. What is building automation? This is all the system with a sensor. For example, air conditioner system, lighting system. When it attached to a smart sensor, it can work automatically. It's called as building automation system. And then number two, fire detection system. And then public address system. And lastly is security system. Okay. Normally it will be integrated together. Okay, so how to show the schematic or a diagram? Okay, a diagram of a process. Okay, so normally if submission, for example, for submission of green building accreditation, so some requirement as a proof of requirement, you need to, as for example, as engineer, you need to propose a diagram of the system installed in the building. So how to show the diagram? So you need to show these three levels. So number one is we go to number three first. Number three, as mentioned by the video, number three, level three is the equipment, sensors or equipment on site, on location. So they have all sensors, for example, air conditioner part and then lighting. So lighting, okay, and maybe fire protection and so on. So at the field level, they are all these services that have been installed, and then this all the field sensor will connected to the controller. Controller is very important. For example, BAC, net, IP, or okay. So this actually has input and output. Has input and output. It will collect data from the field and send to the management system. Meanwhile, if we set something from the management system, we can send to the controller, and the controller will send back to the sensor. So this is very important things to level 2, which is a controller. And lastly, at the management level, number one is the one computer with a server that can have the user interface to show all the system installed in the building. So you should, the diagram should show the connection between each level, right? So this is a simple, which is maybe this is a conditioner part, this one, and this will be water supply. So in a real building, they can be menu. So maybe this is a management system. Sorry, management. And then go to controller. And then this controller, for example, this is aircon level 1, aircon level 2, level 3, and so on. And then another controller can support lighting, level 1, lighting level 2, lighting level 3, and so on. So there are many. So sometimes maybe one management system is not enough. For example, one management system can be monitored by one or two persons. But if every day is too many, they can have several building management system based on the size of the building. Maybe they have if the building have two towers, towers A, towers B, or section A, section B. This depends on the size of the building. Right. Okay, next is features. Okay, so you already know the connections, how to be able to connect, integrated all the system. Next, we see the features. For example, it can for electricity, lighting, conditioning. You can show energy consumption, detect any problem, and monitor and control remotely. Okay. And then for water, show water consumption, detect problem and leakage, and so on. Similarly, with alarm management system. So, but one is important features that very interesting is, as I mentioned before, to create alarm or notification. So, when the system in the field not performing well or problematic, alarm notification can be set if the energy or water consumption exceeding the recommended value. Okay. For example, not only exceeding the recommended value, or maybe less than the recommended value. For example, water. For example, water normally supply 20 liter, but suddenly in that days or weeks, the water supply is 30 liter. So something problem here. Maybe water leakage or excessive use. Ada yang membazir. But sometimes too small water flow. So what happens here? Maybe there is still water leakage or water pressure drop. So still have problem. So we can monitor by the alarm notification. Alright. So last but not least, in this slide, it shows benefits. Benefits of the BMS system is, number one is it can improve plant reliability and life. Okay. Plant, what is plant? Actually, plant is actually the BMS system is set. Okay. To improve plant reliability and life means with BMS system we can have proper maintenance. So we can extend the usage of the equipment, right? Because we manage it properly and prevent it from broken. Okay. Number two is effective response to ventilation and air conditioning complaints. So this is important. So air conditioning system is one of very important system in the building. So if something happens to the air conditioning or temperature is not good, so people will comment. So by the system we can effectively respond. For example, to increase or reduce the temperature. People say during the day is rainy. So the set temperature, for example, temperature is 24 to 26 degrees Celsius setting. But maybe during the months or weeks it's the rainy season, even though this temperature is recommended, but maybe it's too cold for that rainy condition. So they can slightly increase the temperature. Meanwhile, if the day is too hot, when this temperature maybe cannot provide comfort, they can slightly reduce control to ensure that the environment is comfortable. Number three is save time and money during maintenance. So it means because we can identify, detect the problem earlier, we can save time to find, to troubleshoot the problem, and money. Okay, in terms of we can save money in case of we can detect the problem earlier and prevent the equipment to affect another equipment. Okay, normally every system or all mechanical system, if there there is a problem if we do not prepare it as fast as possible. Its vibration or its inefficiency will affect nearest equipment to be broken. Dia akan penyakit atau kerosakan itu akan berpindah ke tempat lain. So to prevent that, by early maintenance, early shutdown, it can prevent the problematic equipment will affect another equipment. So we can save money on that. Okay. Similarly, for improved plant reliability, so to prevent the broken equipment or problematic equipment will affect another equipment. Next, it can increase staff productivity because this is related to efficiency. So when they know what the problem earlier, they have clear picture what happened on the site through the monitoring system, they can increase the staff productivity. Next, we look into a better control. So by the system, we can have a good control of the comfort and condition. So we can set so the technical team can make sure the building runs in the optimum level. So can always provide internal condition, and then the possibility of individual control. So this means individual control means, for example, if there is a room, because of the sensor, we can install one controller in room. For example, controller for lighting, controller for air conditioning, okay, to set the indoor temperature, and can be linked to the VMS system. Right? Next is effective monitoring and targeting the energy consumption. So as I mentioned before, by the system, we can check the energy use and water use. So if anything happens, we can, for example, they use some building some level too much usage of water, so we can inform to the occupants on the level, please reduce water consumption, use water efficiently. And then for example, another example, if the occupants manually set the air temperature too low, we can give them notification the access too lower than the recommended level. So it's very good for communication between the building maintenance and building occupants. Alright. Basically, that is all for today. Okay. I will not go into further. So what to do after this is to do exercise. Okay, some exercise. Listening. So I expect to spend about 30 minutes, okay, for you to find, by online searching, please find a diagram, okay, the system for any one of the following. Right? So such as find example of each one, what the air conditioning system or lighting system or water supply. Right. So how to find a good example? You should have these three level. Please find example that have three level. Okay. And then if you find my good drawing diagram of air conditioning system, and then it means you select air conditioning system, and then from that system try to create two conditions that will trigger alarm or notification of the VMS system. Sorry. Okay. Try to make create, identify reasonable or logical condition that will trigger the alarm. Right. Next, submit your failure and answer in water system in this 35 minutes. Okay. So the purpose of the exercise is to ensure you know the diagram. Okay, because one important thing is you should know how to briefly draw a conceptual diagram of the system. Okay, for each of the system. It can be much more system, but in this exercise, just find one from these options. Okay. So in auto system, I already created the group and then the assessment for individual activities. Okay, so let me active activities. Right. So after you find, please upload here in PDF. Okay, so now we expect we start at 2:40, and then we will end at 2:40 plus 30 minutes, so around 2 3:10. Okay, around 3:10, 3:15, and at 3:15. So after that, I will check your. I will select some of the submission, and then let me discuss. So basically, 3:15 you should submit by try to find 15 minutes or 20 minutes is fine, and then maybe another 10 minutes to create the condition, and then 5 minutes to submit. So is it pretty clear? Is there any question? Okay, so you may start now. See you again in 35 minutes later. Okey, anda ada masa lagi 2 minit untuk memorise ini. Lepas 2 minit, so boleh take 5 dulu. So kita akan continue pada 3.20. We continue at 3.20 for me to download and check your answers. Alright. Okay, we will continue in 1 minute more. So basically, for submission is very good, but now my auto system crashing. So, but I have got several example. Okay, maybe we can start now. Alright, so the question is about okay, find a diagram, example diagram. So basically, from your submission, mostly I found you obtain some student found about air conditioning and lighting system. Okay, so very good. But for water system, not many, eh? Not many. Alright, let's look one by one. So again, the purpose of the exercise is to make sure you know the diagram of the MS system, and also some important logical notification that the PMS system should inform. Right, let's look at first solution. Okay, for this is from Muhammad Abdul Rahman. Okay, so Muhammad Abdul Rahman, he share about the ventilation and automation system. Okay, so the system is good. Right, so this is basically for a conditioner. So what happened here is first thing is management system, and it's named as SCADA. This is name their name for the system, and then has a connection to all the controller Ethernet converter or Modbus. They have Modbus or M-bus, many names of for the controller. So for each controller, it will manage, okay, will control one system, one air conditioning system, which is here. Furthermore, is RH is relative humidity and temperature. T is temperature sensor, and DP is actually a dew point for humidity, dew point sensor. So all these things connected, so it can set and monitor the air conditioner. Alright, so this is actually one pass, and the second pass is also about the central units. Okay, and then it can also manage for the we call it as a AHU unit for centralized air conditioner. So it linked to the Modbus and then go to the air handling unit. We will learn this in chapter 3. So basically, this is a good submission. And then two example of how the system could trigger. So let's see, the heat sensor detect that the heat inside the building too high, and therefore command to we should open the damper, turn on the AC unit to circulate the air. Wow, very technical and detailed. Alright, so you already touch about air damper. So actually in AHU unit has a damper to control flow out. Okay, so the heat sensor can control the damper. A certain blockage in the system is detect the sensor and therefore alert the sensor maintenance department. Right. So if there is a blockage, it will send some information. Something happened to the AHU unit. So very good. Next, about air conditioning also. So figure not very clear, but still, the important thing is we need a figure that shows, diagram that shows all three levels. We have management level at the top, control level, automation level at level 2, and level 3 is the sensor. Okay, so this figure number 2 also by Manoj also good. It shows 3 level, but the information is not so clear, Manoj. So maybe it can be improved later or in further for our study or discussion. All right, let's see what Manoj proposed for the alert. So when the temperature detected is unusual, too low or too high, so need some notification. All right. When a disruptive noise is heard due to system faulty. All right, I think number 2, make sure number 2 is noise is heard. Okay, so basically we in BMS system we work with sensors. So maybe related to noise, to automatically hear the noise, maybe we need to sound sensor. Okay, so when a disruptive noise is heard by sound sensor, maybe, but maybe they have maybe not basically actually not so suitable, but possible if we have noise sensors. All right, next, this is water leakage system. Okay, by Luai Bashir. Okay, thank you for submission. But in terms of diagram, let's see, connection to BMS via volt connection to. Okay, what this is about water leakage system. But in terms of overall diagram, I can say that this diagram is not finished. Okay, so the diagram should include connection to the BMS, but here it shows you inform connection to BMS, so it is okay. But to make a proper diagram for submission, we have to link at least link the flow to the management system.
Noted.
All right, but however, I found that very less students submit about water leak, so very interesting. So what we have here is some control panel, right? Okay, and then go to controller for each water. So water leak detection. But I honestly I'm not familiar with this system. ACU, maybe this is online. It was based on other than Malaysia. So let's say two condition. I for very sorry I can extract information from here, but we can see that this is a controller and this is all the system. Let's say recommended every 0.5 meter. Okay. When the voltage not connected to the control panel. Alright. Voltage, voltage when the water leak outside standard will be warning. Alright, basically related to water supply, normally the sensors will measure about pressure, water pressure, water flow rate, okay, pressure drop, flow rate drop, okay. So in here, maybe this is very brief. We cannot see in detail. Maybe if we go to the website, we can find the detail.
Noted.
Okay. Next, we move to chain. Okay. Also icon. So this is a good diagram. We have all these 3 level and including some circuit breaker. All right. So when the temperature resetting, air conditioning system activate automatically. Controlled by phone. Okay, sorry. So maybe the requirement is not very clear. So what we have, the question is what the notification or alarm that will inform the BMS system. Okay. So next time I need to understand the question properly. Okay. But a very good example to give. Okay, what else? Now we still have lighting. Sorry, air conditioner, Ahmad Abi, alright, still okay. But very brief. Still by aircon, so there are this have many types. There are 4-way aircon, 1-way aircon. Alright, and then the notification when room temperature become too low, we send notification. Auto on off air conditioner by setting the on off time. The notification will send to the controller. Alright, so number 2, I think not correct. It's not a problem. Not problem related to notification. So need to improve here. And then this one, chiller. Okay, all right, not so clear, but it is specifically for chiller. So chiller is one of uh, air conditioning system for centralized aircon. So they use chiller. So the chiller will link into the BMS system. So the detail is not so clear, but let's see the conditions. Once the temperature is increased to higher degrees Celsius, the sensor will detect temperature and inform. Alright, similar with other student lah. When the air quality of the ventilation rate are not standards. Alright, this is very good. It's related to air quality. For example, it has many particulate matter. Particulate matter is if the air is not clean, right? So we previous student previous I also mentioned we talk about temperature and so on, temperature only. So if it's possible, if we can install sensor about air quality, okay, whether too much CO2 level, too much particulate matter. So particulate matter may be related to the aircon filter. Maybe the aircon filter is not very not work efficiently, need to be changed. So this important notification is very benefit useful, very useful. All right, very good, thank you. I'm not sure who is this. All right. Next is about lighting system, right? Chaya. All right. So they have two actually. So one is this figure. Some students also submit this. So similar, we have, but in this figure, where is the management? There is no management. So need to show to find a diagram of three level. Okay, this one building automation system, and then go to the controller, and our controller go to various type of lighting system, right? And also can be linked to the wireless control mode. Yeah, you can control by wireless. All right, very good. Okay, let's see what can trigger the alarm. Human body induction, sound detection. Okay, this is a very. All right, let's be here from Chai Jayan. Can you explain what is this? What do you mean by this? Okay, what do you mean by this? Sound detection, human body induction. So this is actually lighting system only, or with other system? Chai Jayan. Hello? Can you hear? So other student, can you hear me clearly?
Yes.
Okay. Okay, Chai, Jayan, can you hear me?
Yeah, doctor.
All right, can you explain about this condition? Can you explain about this condition?
Just when got the sound, then the alarm will
Sound for what?
when detect sound, then the notification system will.
Oh, so you mean sound of problem?
Yeah.
The sound detection. Do you mean the sound of the lighting?
Sound the people,
Sorry, sound of
the person, people.
sound of people. So sound of people means okay. I think this maybe not correct lah. So okay, so basically for lighting, normally if we can see in terms of energy use, for example, the building of the room, for example, that day possibly around 5 watt per hour, but suddenly 0 watt per hour. Maybe there is some like in terms of energy, maybe the room have lighting system that we have problem, right? by energy consumption. Okay, let's see another. Okay, alright. This is Fika. This is about air conditioning, but let's skip. We have too much example of aircon. Okay, lighting system. Okay, similar like before. Let's see two condition. Alright, two condition that will trigger the lighting system. Alright. The question is not not right. Question is trigger the alarm or notification. Means this condition is for maintenance purpose. Okay. How to what is the condition that will trigger alarm or notification that the equipment is not working well, right? So this thing, okay. So this thing is totally not correct lah. So you said that two condition that will trigger the lighting. So not this question, okay. So right, I see from Abu Hafiz. Okay, two condition will trigger where the notification will alert when one of the lights are broken. So basically, maybe I'm not sure there is a specific sensor for inform if the lighting is broken, but possible that if related to energy consumption. The lighting will turn off. There is no one in the room. Okay, this is not correct, right? Okay, so alright. Next, Abdullah Zaki. Okay, this figure shows you level, and then the light will turn off. Excessive. Alright. Okay, this is good. The light will turn off when there is excessive voltage flow, and then the light will turn on when there is motion. Okay. Number two is not related to maintenance. So can you suggest? So we don't have many example of lighting. So any of you want to suggest what type of condition can be made for the lighting? Ada tak idea? Do you have idea? Normally what condition for lighting?
Yes, doctor. I have an idea. Maybe for the street lighting, we put sensors above the light, and when the down is there, there is not much light. The light is turned on.
I see. Very, very, very good also. In terms of brightness, maybe there is a brightness is not enough. If they can install, we can say artificial lighting or lighting sensor. If maybe if uh, the the design, for example, the lighting sensor, for example, lux, lux, if the measure the lighting is not bright enough, so maybe there is something problem in the room. Okay. Okay, by lighting sense, by we call it as luminance sensor. Luminance sensor. Alright, very good. Thank you. Okay, so maybe two possible is light turn off when there is excessive flow of voltage. One. Number two, maybe if there is no during occupancy, no energy for lighting. Maybe something happen. And maybe number two, if the luminance sensor detect the luminance is not enough, so maybe something happen in that room. Okay, and last maybe Chai about water supply. Actually, honestly, this is not the BMS system, so this is actually water distribution in house. Okay, so no one cannot find for water supply. Let's see if I can reload this. Relativity. Section 1. Tadi stop sampai 20 berapa tadi. Ada yang buat air tak? Water supply tak? Any of you make water supply? BMS system? Okay, tak ada. So I think therefore you can try to explore. So if nobody do for water supply and we have lack of example for water supply, maybe after this you can explore how the BMS system for water supply. Okay. So I have one example, but I think I want you to find out by yourself, right? But the conditions for normally conditions for alarm normally be related to flow and then related to uh, pressure or something else. All right. Is there any question until now? Is it okay? So you understand how to now you know the diagram of BMS system. Okay. If there is no question, I plan to stop here because we already complete chapter 1. So next week, we will go to chapter 2. All right? Is it okay?
Okay, Doctor.
Okay.
Okay.